kind of agenda like regarding question answer. So whether we will take all those questions at last or in between also we
So
can take.
actually, we have collected questions. So we have questions.
Oh, we have
Yeah, we
already
have
collected.
already taken
Okay.
up some questions from our like viewers, people who
Okay.
actually RSVP'd for the event. So we'll plan to do it at the end when we are done. So we'll go for
Okay.
it when at the last of the session. If it is okay with you, like if how would you prefer?
Yeah, that's fine.
Yeah, okay. I think we can start now.
Okay. So should I turn on my video or it's fine?
No, anything is comfortable. Now I want to turn on
Okay.
my video. So
Okay.
either way it works. So
Okay. Okay. Fine. Okay. So let me know when we should start.
yes, so we can start now. I think it's time.
Okay. Fine. Maybe I should turn off the video because. Okay. Good evening, all of you. Myself, Sishir. I currently am working as a data scientist in armsoftech.ar, Chennai. Actually, we are currently working on conversational AI related work. So that means most of the work currently, whatever we are doing, related to the speech or like text, like that means we can say NLP related work we are doing. So I'll just give a brief overview what currently we are working. So we are working on mostly related to the conversational AI and something related to the customer analytics. So we have some voice bots which we call her Vidya. So that Vidya interact with the customer and she knows like what customer needs and like what emotion she has. All those capabilities are there, and apart from that we are doing some kind of like language identification. Then we have voice biometric system. So all those systems we have, and I'm heading a data science team in that Unstructured. So I worked there from last 2 years. So now my uh, agenda of today's talk is what is currently going on in data science area, and like if we want to do some kind of data science stuff, and from where we should start, and what are the things are there in company, and how people are doing like data science in uh, just from industry point of view. So what I have learned and what I have some gathered some experience from last few years, so that I'm just going to share in this talk. So there will not be any maths or nothing will be involved in this particular talk. So I'll try to give a brief overview on that. Okay. So before starting, I think all of you have remembered like in your high school days when you studied maths, maybe in class 9 or class 10, or maybe maybe high secondary +2. So we studied something called statistics, probability, all those things we studied. And we in case of statistics, we computed mean and variance for some sample of data. Then we computed standard deviation. Then we computed median. Then also we did some kind of like we know how to fit a line like y equal to mx plus c. So all those stuffs actually we did earlier. And in statistics, what we did, we plot some bar plot, then pie chart, all those things we did in that time. So basically, actually, if we say unknowingly, we did some kind of basic data science stuff back in our high school days. Okay, so it's now at that time actually we don't know where to use that thing. Like simple mean and standard deviation can do some very meaningful in meaningful stuff in some business applications, or maybe y equal to mx plus c. Using that equation itself, we can do some good stuff for some use cases. So that is actually data science. Now, in this talk, yeah. So this is my outline of the talk. So first thing is that like, what is data science? Like, what do you mean by data science? So I'll try to give a brief overview of that. So in this talk, actually, I'll not talk about how different data science from machine learning, or how different like machine learning from deep learning or AI. I'll just consider those terms as interchangeably. So I'll take all those terms as like similar kind of thing, but that is not the thing. Like, we can assume machine learning, we can algorithm some tool which can be applied in the data science area, or maybe for deep learning as well. Then why data science is so popular? Then what are the components involved in the data science? So what are the things like math, statistics, what are the things we require? Then when we build a data science project, where we have to start, and what is the end, and like what are the main components that will be there in that, how to design a data science project. So that also we'll discuss in the crisp DM. One methodology is there. Then what is the job, data science jobs are currently present in industry or different areas, organization. Then one kind of approach, just 2-3 days year back, people start adopting, which is called data driven approach. So what is data driven, what is model driven approach, that also we'll discuss. And what is the status till now in 2021? So Kaggle has done some study on that, so that also we'll discuss. And how to start if we want to do data science. Okay. Now, before going to the actual topic, I want to show one Google Trend graph, where you can see here, if you type data science in Google Trend, then you will see actually how exponentially this Google data science is trending. Maybe you can see after 2016, this data science term is very doing. Maybe if you see here, this point maybe 2012 or 2010, from where this our devices become very cheap, or cloud computing, or then GPU power, all those things, deep learning is coming, all those things, we got huge amount of data in our hand. So that's why it is coming, and you can see like how exponentially it is growing, that to get some sense of that. Okay, now before going to the data science, now what exactly data is? So I think all of you might have know, like we have different data, maybe in different format. So that's why people divide the data in two categories. One is structured, and another one is unstructured data. Then what is the structured data? So structured data are like those data which will be in the tabular format. It may be a Excel sheet, or maybe a CSV file, or maybe the SQL table in your database. So all those things where predefined rows and columns will be there, and we can easily get those values from that rows and columns. The searching of the data will be very easy in that sense. Then some kind of data will be your unstructured data. So now majority of the data after the big data revolution are the unstructured data. So unstructured data are audio, text, speech. The rise of the social media network and the rise of your dynamic web pages, when the user can actually give the data to the to one website or any media. So after that, actually the rise of this kind of unstructured data is exponentially growing. And now we can see there's some statistics from IBM and all. They did like in a most of the data, maybe 80%, around 80% of the enterprise data in one organization data is unstructured data. some organization, maybe or maybe some industry or any other organization, you will also feel that situation. Actually, it may be more than 80%, maybe 90%, 95% of data your will be unstructured data. If that is a real AI company where their work is maybe related to the speech or image or text related work. So having said that, now coming to, we understand like what is the data. Now what is the data science? So I may not be that like expert to give a definition like what data science may be, but what I understand and from my experience is that, so data science is a assortment of different tasks. So data science not a single task. For example, we can't say that cleaning or modeling, building the machine learning model or cleaning the data is not actually a data science. What we can say is that it is a combination of different tasks from to uncover the useful intelligence from the data for some application for some enterprise. Then what are the different tasks is involved? So first point is the collection of the data. So if we don't have the data in our organization, or we may have the data in my organization, but that may be in a very raw format. So how to process the data, okay, and how to store those data. Then after processing the data, where how will describe the data, because from the data whatever we got, we will do some kind of processing. That after doing the processing, how we'll describe those data, because we need to check whether we need to do some kind of visualizations, we need to do some kind of statistical analysis, so that we will understand the data. And then once we get the understand the data, we have to extract the features and whatever the features are there, and what features may be relevant for our task, and whether it will be a classification problem or whether it will be a regression problem. All those things we need to identify after that, and then we need to select some model. It may be supervised model or maybe unsupervised model, or nowadays some self-supervised model. So those kind of model we need to select, and then we need to take our model depending on the data, whatever the data and whatever the problems at our hand. So after doing that, we have to evaluate our model, because we need to check, we need to divide some portion of the data into test set, and we need to evaluate our model, whatever the evaluation metric we have defined while doing this process. So when we get good accuracy or any other evaluation metric, what we need to do, we need to deliver that model to the other team who maybe deploy the system for user to use. Then again user will use the system, then give the feedback. That whole process we'll discuss in the subsequent slide. So what exactly now data science is that we have some kind of data, it may be a raw format, and from that data we need to get some information, and we need to process the data, and we need to communicate with the required person. So that communication is an important thing in the data science. So you need to tell a story, how exactly whatever you are doing, what feature you have using, and why you are using that particular model, and why you are getting that particular result. Everything you need to communicate properly, and you need to give some insight out of that. So that whole communication process is the essential part of the data science. Then I took one quote from one of the very well-known person. So the ability to take the data, to be able to understand it, to process it, to extract the value from it, to visualize it, to communicate it, that's going to be a hugely important skill in the next decades. So that's what the actually data science is. Okay. So also CEO from HP also told that the goal is to turn the data into information and information into insight. So that insight we need to get from the data. Now, coming to the why data science is so popular. So that we need to understand that. So why data science is so popular? So for that, the researcher or the expert suggests that there may be three reasons actually. So first reason is that huge amount of data is available in our platform, in any platform. It may be social media or it may be e-commerce. Through different activities we are gathering huge amount of data, which was never ever happened earlier in maybe 20 years or 30 years or 100 years ago. So that is actually we call the big data revolution. So different sensor will be there in the Internet of Things. IoT devices are generating lots of data through each sensor. So how we'll process those data? So for example, we have one e-commerce system. Maybe we can take example of Amazon. So they are generating huge amount of data. Now what they will do using those data? So now that is the first question is will be there when some organization will generate huge amount of data. So what they will do using those data? So first thing is that if we can do something useful or something insight, if we can extract from that data, so that the business whatever the business they are doing, maybe 10%, 20% improvement will be there in their business revenue generation. Okay, so that's the idea actually. So get the idea insight from the data, and we have to give feedback to the business team, and that business team maybe implement will utilize that information, and overall that revenue generation will be uplift using that. Then this is an important thing. There were like 5 exabytes of information created between the dawn of civilization through 2003, but that much of information is now created every 2 days. So you can also everyone will know is that like in every second how many YouTube video is uploaded every minute or every day. So that huge amount of videos, huge amount of text data, huge amount of speech data is generating by in every second. So that's the actually one motivation for the data science task. Now second thing is that earlier if you check if you read the history of neural network, so neural network was proposed long back, and when Ian LeCun proposed convolutional neural network maybe 1996 to recognize the to do the digit recognition. So at that time people keep the use of neural network become decrease actually. What is the reason is that because we don't have that amount of data to train the model, and second thing is that we don't have that computing power, and we don't have that much of resource. We may have the resource, but problem is that it's very costly. So now after maybe you can say after 2000 we have a huge amount of capacity of storing the data in very less amount of price. That is one factor, and second factor is that compute power. So now GPU price is very less, so we can do this floating point operations per second is exponentially increasing. So that is one factor, and second factor is that third factor is that like cloud computing. Now we can run any experiment on cloud. So for example, we don't have we no need to have a GPU to run very simple experiments. So what we can do, we can take Google Colab for that. So just use the Google Colab GPU instances or maybe TPU instances to run your code. So that facility was not there in earlier days. So that's one reason. Like devices have become very powerful and cheaper. Then another very important part of the beauty of AI and data science is that whatever currently people are doing, everything is in open source. So that's the very usefulness thing of the data science area. So open source movement is democratizing the data science. So if you talk about like different component, maybe codes or different frameworks to run your machine learning or deep learning algorithms, or maybe where you will get the data, because no one can if I want to start some work, I may not create my own data at first. So how will run my code then? How will use my data? So that public databases are there. So, and also we have pre-trained models. So if you consider for codes, like we have GitHub and Kaggle. So for in those platforms, you will get huge amount of codes. Like for any kind of machine learning models or any kind of codes, you will get in the two sources, or different frameworks. Like earlier, when you do some kind of modeling, maybe you need to write the code from scratch. But nowadays, scikit-learn is there, or for machine learning, you need to write maybe 2-3 lines of code to just get the results. So that process become very fast now. So you get the data, then just process, then build a model, and you can check your evaluation result. So that process of doing that actually accelerate the data science, whole area of data science. Then this pre-trained model means, for example, you have one task, that is image classification. Now you may not have good amount of data for doing the image classification. So what we can do is that somebody, maybe Facebook or Google or some open source community, they have that access to that huge amount of data and computing power. So they build a model, maybe some 1,000 class classifier they have built, maybe some CNN system or any kind of machine learning system, and they release the model as an open source system. So what we can do is that we can just take the model and we can do the inference in our laptop or in my compute. So that is one thing. And another thing is that if we have some less amount of data, so we can do some kind of fine tuning using that particular model. So that process of doing actually accelerates our whole data science area. Now, what are the basic components is there? So first component that everyone believes is that domain knowledge. So that is very important aspect of the data science. Just take an example. We are working in a financial domain, for example. Now, how transaction happens, for example, credit card, debit card, or any loan related transactions. So that domain knowledge I may not have. Okay, so what we need to do when we do this kind of project, we need to communicate to that particular person who has that knowledge. Okay, and we need to acquire that knowledge so that we can select our features or we can train our whatever the required model. So that domain knowledge is very important factor in the data science. Then coming to the statistics, we should know the statistics. We can't skip the knowledge of the statistics and whatever the maths, maybe you can say linear algebra or probability related work. So we have to learn. We have to give very dedicated time while learning this statistics and maths specially. Then we need to have compute power to train our model, and then we should have that visualization tool also. For example, we need to check how my mean is deviating from one class to another class, and how we can do some kind of graph, maybe some bar plot or some kind of scatter plot to check the data, like how it is distributed. Okay, for doing that, we need to have that exploratory data analysis. So those things will be required, and we need to have some knowledge of the data engineering. So how we manage all those data, because we have huge amount of data, how we will manage that data. So that's related to the data engineering part. Now, if we talk about this data science life cycle, so first thing is that we need to capture the data. Then after capturing the data, as I mentioned earlier, we need to store somewhere. So we need to have different kind of data processing, data warehousing, data cleaning. All those stages will be there. Then we can process the data. Maybe we can do some kind of data mining there, and then clustering, classification, whatever things are required. All those things we need to do. And then we need to do this analysis, like exploratory, some predictive analysis we need to do, and do some regression or qualitative analysis. Then after doing that, we need to communicate that thing with the team, that maybe it may be the manager or maybe business team. All those things we need to communicate. So for that we need to do some kind of data visualization, some kind of report generation we need to do so that based on that the business team can take the decision. Okay, so now coming to like if we I am talking like we have huge amount of data in public domain. So where we will get exactly, like specifically where we will get that? So I have listed out a few links. I think you may also know about that. So in Google dataset search, you can search any kind of database, so it will point out to the particular link of that. So in Kaggle, huge amount of data every day, people are uploading data in that. Then these are for general. You can get audio, video, text, or tabular data. Everything will get. Maybe some biomedical data also will get. But this Common Voice Mozilla, this is some open source project from Mozilla. They released that. So this Common Voice, you will get only speech related data, and you can also contribute. Like for example, we want to contribute for Assamese or maybe Bengali or Hindi or any other languages, so we can actually contribute using this Common Voice. So you can create one account and you can contribute your voice to here. Then OpenSLR also one project. You will get huge amount of benchmarking data in this related to speech in OpenSLR. Then here you can get some Indian related data, speech and NLP related data will get. So this LDC also you'll get, but we need to pay some amount in that to get that data. Now one very good thing about this is that now I think you may know about Hugging Face. So this Hugging Face, what they are doing is that whatever the data I am talking about, maybe this main data. For example, if I talk about speech, so we have one database called LibriSpeech. So that is a very well-known benchmark data. So those data they directly you can call using the database object. So in Hugging Face transformer, you will get some database object, we can say. So through that you can get the all those data. You no need to do any kind of processing. Already Hugging Face did those processing. Just you need to install that package, and then you can get the data in your terminal. Then this is a new initiative actually, XStep Foundation. So they are doing very good work related to, currently they are doing work in speech area. So they are releasing huge amount of data and some pre-trained model as well. Then this one is Sri Arvind Machine Learning Repository, very well-known repo where you will get some banking related data and some biomedical related data also you'll get. And this link you can search some speech related database if you want here. Now how we should develop a machine learning a data science project, for example. So what are the steps? Just assume that in one organization someone asked you to do a data science project. So now what will be the steps first? So this whole methodology expert role as the CRISP DM, cross industry standard process for data mining. So earlier this process was used for data mining, now people adopted for the data science project as well. So this has 6 cycles. So first cycle we'll understand what each cycle is one by one. This business understanding, the data understanding, data preparation, modeling, evaluation, then deployment. So let's go one by one. So before that, one important factor about this whole methodology is that when we build some model, for example, it may be a data science related project or maybe some simple machine learning or deep learning project. So what we do generally is that when someone asks us to build a model, what we do, we check like what are the available databases there. So at initial time we may not have good amount of data. So whatever the data we have, so we build one minimal viable product. So we call this MVP. and establish the benchmark. Like what we can say is that if we have this amount of data and we have this amount of understanding about this data, and we know that this will be the out product, and we know for this amount of data we should use this model. So if we know all those things, we build one very basic model. In terms of model, I can say, or in terms of product level, we can say it is a minimal viable product. And then what we will do is that we'll integrate all the basic components of the product and deploy that for the live testing. So we know that model may not be very good. So when user will use that model, you'll start gathering your data. So those data are the real data for you to get the to make your model better. So that process will be every time it will be a like kind of cyclic process. So you have to take the data from user, then deploy your build a model, again deploy. So like that you can do. Now this whole process, maybe I'll go this process later after discussing each point. Okay, so now business understanding. So when someone will ask, like your business team will take one project proposal from someone, then what we'll do is that we need to understand. They will tell like this is the project we need to do. So we need to understand the business objective, okay, and we need to understand the requirements. So what are the requirements we should have? So what are the priorities of that? So and then we need to understand whatever the requirements are there and whatever the objectives are there, whether it is a doable using the data science work. So that also we need to understand, because we can't do that work if it is not doable using using a data science technique. Then we need to check, that is the thing, why can data science achieve those objectives. So we need to understand that. Then what is that story to tell? Because once we get that project, then we have to tell a story. For example, from where to start and then how to communicate that result. Everything we need to plan accordingly. So for that we need to tell a story. Then what will be the success metric? So for example, we build one model and we deploy that model for user to use. Okay, so now so there should be some success metric. So this success metric is not related to your model evaluation metrics, maybe F1 metric or maybe accuracy. Is not like that. So it will be some business metric that business people will define that to evaluate the whatever the product or whatever the model we have developed. Then is there any ethical issues with using the data? It may be, if it is maybe some call center related data or some biomedical related data, we have to, or some credit card business, some financial transactions are there. So we need to understand that. Okay, so that also we need to understand. Then second thing is that we need to have the benchmarking, because we need to check if other industries or other organization is doing that particular project. If somebody is doing, so what we can do, we can understand, we can check if anything is there in online available or anything. Then you will get some benchmarking there. Okay, then just assume everything is fine with the business team. Then what we'll do is that we'll discuss what will be the source of data. Okay, so now in that case, I'll give one example. You want to build one speech recognition, which will convert your speech signal to the corresponding text. So in that time, we need to understand from where the data will come. So whether it will come from some headset recording, or whether it will come from very noisy field, or maybe outside the data, outside your office or inside the office, or maybe some telephone mobile channel, or some VoIP is there. So all those things we need to understand that. So then only we can build our model depending on that. So, and we need to ask is that whether new data is available or new data is to be collected, or already some existing data is there, and whether if it is available, whether it is relevant for our project. Because for example, you have telephone channel data recorded through telephone and very noisy kind of data you have, but your application is very clean environment. So that mismatch will be there, or some speaker mismatch, all those things will be there. So those things we need to avoid that. Then those things we need to understand that. Then the coming to the data preparation. So in the data preparation, the data may be from different format. So if one organization is storing in a data in different format, some other organization may store in a different format, and inside the organization also people may store the data in different formats. So you have to understand all the formats what people are doing. Now if it is done, then whether it is annotated or not. Okay, so whether proper levels are there or not, whether some human intervention will be required or not. So all those things we need to understand that. So whether ground truth is available or not. So you may come across some project where you may not get the ground truth. So how you will get the ground truth by doing some kind of unsupervised kind of way of doing, or maybe some semi automated process. So all those things we need to get that. Then we need to do some kind of this transformation. I think you know about that. Like for example, this is your Excel data where data may be ranging from in one axis it may be ranging from 0 to 100, one may be 0 to -1 to 1. So all those things we need to normalize. So there are different normalizing techniques, zero mean unit variance, or maybe you can do some standardization. All those things is there. Then we need to prepare one train set and one development set for that particular data. Okay, so 1 second. Okay, so then coming to the modeling part. So we are going to build some kind of model out of that data. So since we have separated the train set and test set, then what are the assumptions to make for this model? So if we have that training set, so now we need to build a model. But before doing that, we need to have some kind of assumption for, just like how many, for example, what will be the configuration of the model and what this model can do for this particular data. So all those things we need to decide for that particular, because for example, you have very small amount of data, you can't use a very huge deep learning model. Or for example, you have a very basic simple some dependent variable and some independent variables are there, one independent variables are there. So you can't build that, you can take that data for building a very huge deep learning method. So you need to understand, like maybe in some application linear regression model only will be fine for the task whatever we are currently doing. So we no need to do some kind of very complex regression algorithm for that. So that also we need to understand. Then we need to check whether this data is sufficient for the modeling or not, whatever the modeling so we need to do some kind of statistical analysis maybe. Then we should check some statistical significant features, which features may be more statistically significant. So all those things we need to do. And then which framework to be used for building the model. Then what will be the compute resource? For example, you need to build one speech recognition system which having maybe 1000 hours of data. So you can't train that model using maybe some 8 GB or 12 GB GPU. So you need some good amount of GPU with more RAM or more number of CPU cores. So all those things we need to determine, and we need to give the requirement to the concerned team. Then once we build the model, as I mentioned, we separated the train set and development set. So why I am telling development set is that actually in really we don't have that test set, because we are not doing the testing in the real life scenarios. So that's why we are separating some data for doing that development. So whatever the model we have trained, we can do some kind of another segmentation also. For example, train set, then the development set or test set also, where using the depth set we can do the tuning of the model, hyperparameter tuning of the model, and then in the test set we can just test our model. So that also we can do. Then for testing we need to define the evaluation metric. So which evaluation metric you are going to use. So generally just take an example. If it is a simple classification problem, where data is very well balanced. So in that situation, maybe you can take accuracy as a evaluation metric, but your data is very skewed. For example, one class is 1000 example and other class maybe 10,000 or that many examples. So this situation happens generally if you do some kind of biomedical related work. So how you will handle that? So what evaluation metric will be fine for you? So that also we need to decide. So all those parameters is very important, very important. So maybe I'll give one example. Just assume you are going to build one classification system for some kind of biometric devices. Okay, so in that situation, what will happen? You can't use accuracy as the evaluation metric. So there may be some kind of equal error rate kind of thing you can take, but what you can take is that there will be different measure. For example, false positive or false negative. So your false positive should be 0. Your accuracy may be very good, but your false positive is somewhat, maybe false positive is somewhat some percentage you are getting, that will not be good. So your false positive should be 0. Then only no false, like some person can spoof that thing. So all those things we need to determine before doing that. There are different measures for different problems, like regression, what we do generally, all those things are there. For unsupervised, what we do, so all those things are there. Then we need to check while doing this evaluation, we need to check whether the performance requirement was there, whether we achieve that requirement. So in that requirement, I'll just give one example. In the requirement, that whatever the team assigned the work to you, they told that your accuracy should be 90%, for example, and your model size should be, for example, 10 MB, and your response type, because when you do the when you put this model for deployment, your response type will also be an important factor in that situation. So that response type may be 1 second, but you got the accuracy is 95%, but your model size become 20% or 20 MB, or your response time become 2 seconds. So that model will not work for that. Though accuracy or that evaluation, whatever you have done, it is better than what they are expecting. So then again, you need to search from some different model, or you need to prune that model so that your model size will be less or your inference time will be less. So all those situations will come. So that's why we need to check that. So we need to have some kind of unbiased testing on that. Then come to the deployment. So in that deployment, we need to check what hardware stack or software stack we are going to use for the deployment. Then this inspection of the latency size, all those things are very important while doing the deployment. Then any privacy requirement is there, or whether it is meeting the user expectation. So that thing will come. Then if you go to here, so first thing is that business understanding, we understand that. Then data processing. So this part will be interchangeable. Like we can give some requirement to this team. Then they give the data, but we check that the data is not up to date, not what we are expecting. Then you can just give the feedback. So all those processes will be there. Then once you understand the data, you put the data processing, then do the modeling. So in that time also, you need to check, like you found that these features may not be useful, or you got some problem in the data, you can have some other data preparation task. Maybe you can do some kind of augmentation or other processing you can do. Then you get that model, then you can do this evaluation. So after the evaluation, what we need to do, we need to just again go put to the business team whether their requirements will be satisfied or not. Then we'll go for the deployment. So this process will be it will be in the loop. So it will be a cyclic kind of process. Okay, so then okay, so now coming to the what are the roles in data science industry. Then there are actually different roles will be there. So first thing is that and generally what happened from my experience, I am telling that these things are not very defined actually, especially in India. If you work in a startup kind of thing, so you may work from data cleaning, data processing, then model building to your deployment or everything. Maybe you have to do that. Okay, you can't say that I am not expert of that particular area, so you can't say that. So maybe some organizations very specific roles are there where they will do only that part only. So but this depend on that particular organization. But for some area, for example, speech scientists or research scientists, they have some specific use case actually. So for speech scientists, you can do only for speech related work maybe, or maybe NLP engineer or this business intelligence person. So those areas, some specific areas are there where you will be asked to do only that particular area only. But in overall, if I say machine learning engineer or data scientist, you may need to work in all the things like maybe deployment, some part of the deployment, data cleaning, visualization, everything you need to do for that. So this graph, this block diagram is showing actually which what the task of the data, what task of different person. In ideally, I am telling. Okay, so now earlier when people do that deployment or model building, at that time what happened, just we took the data, then do the deployment. But now one thought process, people are maybe from Andrew Yang or all those different kind of experts, AI expert, they are suggesting a different paradigm. So where earlier whatever the approach we are doing, so we have to change that approach of doing the data science. So that earlier approach, whatever I am talking about, is called a model centric approach. So whatever I discussed earlier, so most of the things are model centric approach. So what is the model centric that I'll talk about? And to move to the data centric approach. So if I talk about the data science system, so it is the combination of code plus data. So code means it may be model and algorithm, everything, and then we need to have the data. So that's just and summarize this this whole data science system or AI system in this simple equation. Now, what model centric approach is that? Whatever the approach currently, maybe we do when we first start our data science project. So what we do first is that we take one data from maybe Kaggle or OpenSLR or any kind of repository. We take one data, and then we take the data, and then we check whether it which problem we are going to solve, and then we take one model or take one classifier or maybe regression model, then we do compute the accuracy or mean square error, whatever the evaluation matrix is there. Now, if we get, for example, a 90% accuracy, what we'll do, we then go to the maybe next model, maybe some other advanced decision tree, maybe decision tree based regression model, or other some maybe advanced some other regression model, something we'll do. Okay, so now that way what we are doing is that we are fixing our data. We are not doing any changes inside the data. Our data is fixed, and but we are changing the code. So that is the process currently we are doing. But in industry, actually, we are not doing that. So that we are taking the code and we are just fixing the data. We are changing the code. Okay. So now what people are telling is that what you can do once you work in the real world data, the situation may not be that. Okay. So there may be very noisy data or very lots of data where you need to have some kind lots of cleaning. So then what people are suggesting is that you can fix your code, whatever the basic baseline or basic codes you are doing, whatever the state of the art model for that particular area, you can take that and you can iterate the data cleaning process and iterate the data process. So that's called the data centric approach. So earlier the approach, whatever I talk about, that is called the model centric to the data centric. Now the transition from the model centric to data centric approach arise a new area of work, actually new area of skill. So that I'll talk about. So now in this source you can go, there is one very good YouTube video is also there, and also Coursera gave some course on this particular skill, which we call the model ops, ML ops. Okay, so now let's see what is the advantage actually. So he did some experiment here. So the baseline result is this one. He did some 3 experiments, still defect detection. Just take this experiment only. So baseline result, he took I think some CNN architecture only in this particular task. Then using model centric means he kept the data fixed, and then take the code different, maybe different code he has analyzed, but there is no much improvement in that. Then in the data centric approach, what he did, whatever the baseline code is there, that kept fixed, and clean the data, and whatever the data processing is required, whatever the error analysis, everything, some standard way of doing that process is there. And that when he do, you can see like it become 93%. So that motivates the transition from this model centric approach to the data centric approach. Now this rise to one approach, one area of work called the ML ops, so machine learning operation. So maybe most of you heard about those who are from maybe CSE background about the DevOps. So DevOps is the main part of an organization. When we build one non-AI software, then how to deploy, how to manage that thing, and those tasks taken care by the DevOps. So we have some standard way of doing that thing. We have standard protocol. So we can say that general software, whatever the DevOps will be there. So for machine learning or AI or data science system, the ML ops will be that thing. So if you search ML ops in the Google trend, you will see sudden rise from maybe 2018 or 2019. So this is a very new area to work on. Maybe whoever is interested, you can go there. But the thing is that you should have some skill of core computer science with machine learning. So that maybe you can take as a very good area of interest. So as I mentioned, so here the data is fixed and iteratively improve your code or model. Here I have taken this slide from one of the video from Andrew Nang. So here like hold the code fixed and iteratively improve your data. So this you can read here. MLOps most important task is to make highly high quality data available through all stages of the ML lifecycle. So now, what is the importance of the ML ops? So that we can ask. So what is the big deal of iteratively process the fixing the code, iteratively process the data? So the problem is that in a big organization you will get huge amount of data. So how continuously you evaluate the data and feed to that data to the particular model, and then doing the training. So that whole process. For doing that process, actually standard protocol some people have established. So that is called the ML ops. Very new area of area in the data science area. You can just check that maybe. So I'll take maybe 5 minutes. Gayatri, is it fine if I take 5 minutes?
Yes, sir. Whatever. Like, just we are enjoying your session so much that time doesn't matter. You can just go on.
Okay, thank you. Okay. So now, how to start? So just I'm giving just basic steps that maybe you will get a very good way of step-by-step doing the data science thing in internet, or video expert from different expert, very experienced expert. Just I'm giving an overview is that. So what you need to do, you need to learn one coding, maybe Python or R. Okay, that is the basic thing. From R also you can do lots of things. Then this second point actually, I have seen lots of videos and lots of maybe courses where you can people tell that you can learn data science within maybe 2 weeks or maybe 3 months, like that. But that is not the case actually. So because you have to understand the maths behind that. If you are really interested on doing the data science, because what will happen, you can do data science maybe 1 year or like that, but if you don't understand the what maths behind that, so how you will evaluate your model and how you will fix the problem if you are getting some issue in that. Okay, so the coding is important, and this is also very important part of that. So that's why I am request all of you, just check the probability, linear algebra, everything. You take a very at your own pace. There are huge amount of courses from like famous professor on probability, linear algebra, and statistics. You just learn that, and they try to code that on Python, whatever the linear algebra and probability. And second thing is that when you appear the interview, they will not ask you the, especially for the general data science related work, I am telling, they will not ask you very high-fi thing, maybe CNN or transformer, nowadays transformer is coming, or those things they will ask maybe at the later point of time. But the first thing is that what is your understanding on the probability, linear algebra, and statistics. So that will only they will ask at the beginning, your maths, that means. Then take a very good data science or ML course. I have selected some of the course in the upcoming slides. Then learn this EDA thing, then some feature engineering thing, then linear regression to neural network. So you have to start from the linear regression to neural network. From, as I mentioned, from interview point of view also I am telling. So you should understand this linear regression very nicely actually. So from linear regression, then logistic regression, then decision tree, these are the main things which maybe interviewer will ask in your interview. Okay, so that you have to understand that. And another thing is that when you implement your algorithm, then only you will understand actually what is going on in that. And you can learn some basics of SQL, just how to store the data. But anyway, you can't store speech or other thing, but at least to do some basic thing. And then also you can learn something related to these APIs, like how to deploy the model. Very basic thing. It's very easy nowadays. There are different maybe different fast API or like Flask is there, so you can learn that. And then most important thing is that whatever you learn, just write down that, because in data science you also need the communication skill, because how you will communicate your result and how you will communicate your whole data science project as a story. So that is very important. So that also we need to learn parallelly. So that's why just you can write some blog also nowadays, mediums and different things are there. So then here also I just mentioned the same thing. You take a problem, just identify if it is a classification problem or regression problem. So this I am giving more stress. You may not feel like now, but when you work in some real data, it is also quite difficult. Whether it is a classification problem, it will fall to a classification problem or a regression problem. It will be quite difficult to judge that thing. And also it will depend on the what is the requirement. Then identify the input and output, then take some basic model, just implement that result. Then when you implement, then you will get the result, loss function, optimization algorithm, everything you just implement by yourself. Then you take the data and feed to your scikit-learn model, then check whether what the accuracy you are getting, whether you are doing the same thing or not. Because when you implement those things, you will understand what is the epoch, what is the iteration, what is the batch size, all those parameters you will understand. If you do in scikit-learn directly, if you do, then maybe you will not understand, or in PyTorch also. So you have to understand that. Then try to optimize your code. Then I'll come to this later point of time. So I have written here some useful links. So this is for the monitoring of your machine learning model. For example, you build one, you are training one model, and then what happened? Your system is at home. So then you have to go outside maybe for some work. So then how will you check that model, whether it is working, it is training fine or not? You can check that. So using this 1DB, actually you can weights and bias. So you can check your training trajectories, like whether it is how loss is going from your mobile itself. So that facility is there. So all those things you can check that. Then some courses are that I recommend all of you to go through this course. Actually, it's very nice. I think for student it is only 1,000 from two faculties from IIT Madras. So it's very excellent course actually. So you can take this course, and they have some deep learning course also here. And the thing is that They have this professor named Mitesh Kapra. So he has some other course on deep learning on YouTube also as well. So that course also you can take if you really want to you want to learn deep learning from the maths point of view. Whatever the underlying maths is there is explained very nicely actually, and this is a very new course given by Ian Likun. So you can actually you can learn this code, and you should follow this person Alfredo. So his Twitter, I have given that Twitter handle also, so you can follow his Twitter, because if you follow that Twitter, so you will get huge amount of resource from that Twitter handle, because in his trade actually you can get huge amount of resources to study. Okay, so there are different links are there, you can just go through. So here also, if you want to learn spoken language processing or speech related work, so this course is very important. If you want to learn about the deployment related work, so this is a very new course from Stanford, so that also you can learn. So this Distill and this Zai, I think Alamar, so this he actually explained very nicely. So if you want to learn about transformer, BERT, all those kind of techniques, you can go through. He's explained very nicely actually, so that you can check. And there's some free books for machine learning also I have given here, and some Twitter handle or trade, maybe Facebook, Discord server or Slack channel. So you can follow all these things. So if you have Slack and Discord in your mobile, so you can just log in that. Also this person Abhishek Thakur also you can follow. Din Fefili also you can follow. So actually this person you can follow for different, and for this Lex Friedman, I think maybe you may know his podcasts are excellent. Like he interviewed lots of expert from Ian Lekun, Yan Ruang, everyone. So you can watch those video to get hold that. Another some ML related news. So this, you can see this top data science and AI trend for 2020. You can see this MLOps is the first one. MLOps will acquire weight in operationalizing and scaling AI ML. So this is very nice skill to have actually in this era of the data science. Okay, so these are just few courses where you can opt if you want. Some graduate course like offline course or online is also there. So you can have in IIT Guwahati also they have 2021 they did some course. So, yeah, started some course. Okay, so I'll before going that I'll take another 5 minutes because I just want to show this thing to you, all of you. So this is Kaggle report on data science. You can go through this. I have already shared that. So I'll show you one important, like for which country, how many data science related positions people are there, what age, all those statistics they have done. It's very interesting. So what higher education you required, so how many persons are there from bachelor, how many from masters, how many from PhD, all those things are there. So then whatever the learning platforms are there where people enroll more, so all those information you will get from here. Okay, you can see here some people like who has very less experience, so we also they are in data science area, so that's why you no need to worry about that. So that all those things like how it's very like it's totally different, like how US pay and India pay for two data science, so that also you can check. Okay, then data science team, then how much people are spending over the cloud for doing that. Then what technology, if you go here you can see like what popular ID like ID people are doing, maybe Jupyter Notebook. Then Jupyter Notebook also people are using for data visual, just to get that visualization everything. So that is there. And then coming to the methods, so if you see like linear regression or heuristic regression, so it's very simple and very basic one people are using most, because lots of the application in general data science actually needs that simple heuristic regression and linear regression only for doing that. Okay, so you can see how people are using BERT and transformer. that also you can check. Yeah. Okay. Then other popular ML networks. So there are all those things you can check. Like there are different frameworks, scikit-learn, TensorFlow, everything is there. So we can have that. Yeah. Okay. So then coming to, I'll take maybe 2 minutes of that. Okay. So last year actually we started a community. Gayatri is also there in that community. So we started a community, we called it Assam AI Initiative. So this is a community, non-profit community. So what we are want to do is that though it name is Assam, so don't confuse that we are only related to the Assam only. This is a community where we want to grow this community, so that using this platform we want to learn, and we want to get together, or we want to connect different person who is working in the data science or AI related work, maybe from biology, maybe from physics, maybe from not necessarily from the CS or EEE background. So everyone which are working in the data science area, we can just come together and we can have some network, and we can transact through our knowledge. So that's our idea. And now we are currently doing some kind of in group events, or some open events, like we are inviting speakers from different all over the world to deliver the talk. So you can just go through about that. Maybe you can check. I have put this link also here if you want to join this community and grow for data science related work. And we are having some weekly research discussion as well, where we discuss research papers. Then whatever we are currently doing among the group, we can just discuss, and we can have that some kind of things. So that everything we are doing actually in this So you just go through about that. We are having some planning of mentorship kind of thing also, through which actually we are going to we are going to group certain team depending on the project area, maybe computer vision, speech, NLP, and we want to assign some mentor from IITs or industry who can mentor that particular group to grow and to get more exposure of that. So all those plans we have. So maybe you can just go through about that. Okay. So any question?
Thank you, sir, for your session today. I don't think we have questions from the audience. We have some of the collected questions, which I'll read out to you. So, one of the most asked questions is, what is the difference between a data engineer and a data scientist?
Okay. So that's a very important and interesting question actually. So earlier, I think in one slide I mentioned that generally, if you consider, like, if you ideally, if you see, data science should work from your model, for your data collection, then evaluation, then building the models to your deployment, some sort of deployment as well. Okay. But not much about the data managing part. But this data engineer, they are more specialized to the data managed part actually. So you can just say some part of the ML ops kind of thing. So they are just managing the data and deployment related work. So all those things they are taking care. Not much involved in the maybe in the data visualization or feature engineering or data modeling part. So that's the main difference, ideally.
Okay, so thank you. Sir, our next question is, so why are there differences in how we put, like, for the metrics, when we talk about that, why are there differences in logistic regression metrics and for NLP metrics? Why can't we have the same metrics for all these different types of techniques?
Okay, that is an interesting question. Actually, what he is asking is that why we can't have a metric, for example, mean square error in logistic, in linear regression or other kind of error, to the NLP, maybe Blue Score or other Blue Score,
Yes,
all
yes,
those
I
things.
think something like that. Yeah.
Okay, something like that. Because thing is that because that metric is dependent on your task, as I mentioned earlier. Okay, so that task, for example, we can have that metric also, but how we'll evaluate that? So that's why this having a metric for a specific task is also a research actually. Because for example, if you want to do want to work in a very new area of that, so how you will evaluate your evaluate your model, so that itself is a actually research topic. So that's why we can't actually do that thing, like we can't combine or we can make everything uniform. So then if we go uniform, make it uniform, then we can't actually justify and we can't actually evaluate the model satisfactorily. So that's the thing. That's why we are telling about like accuracy is some kind of general, wherever you want you can just apply that in some way maybe, but that accuracy may not give that insight what you should have actually, than the some other parameter, other metric. So that's the thing actually.
Okay, so thank you. So actually, our next question is, what is the difference between the kind of internships that we do academically and industry? Some of the internships offered by big companies like Amazon and Microsoft. What is the difference between the internships provided by these companies and the internships provided by academic institutes?
Okay, so I don't have that experience doing in Amazon or Google, but just from my colleague and from my other peer group, I just am telling that uh, that some area is there. For example, when you do internship in, it depends actually in the company to company, but in some company you may work on the real data, whatever the data is there directly you can access to that data, or maybe you can get some real world data to work on, or whereas maybe in university you may not get that, but that may not true in all the university. So that is also one important thing. So in some university maybe they may have that access to the real data or real world data and can directly process that. So it depends, like which university you are going, and that's the thing. But yes, in industry will get some more exposure of doing that real kind of thing stuff.
Okay, sir. So our next question is it necessary to have a master's degree to pursue a successful career in data science in India?
No, that's what, like you can, if you see this Kaggle report, so it is showing actually. That's why I showed this thing. So you can see here like this degree with how many percentage of people with even less than 1 year experience, or even, yeah, you can see here this master degree and degree, maybe you can see here. So this bachelor degree, we saw lots of people which are working on the bachelor degree itself, doing excellent work. So that's your, if you want to do some higher education, then you can do that. But if you don't want to do that, you can directly enter to the company and you can directly learn that. So there is no issue, but that depends on, like, if you want to work on, do pursue the higher studies, maybe PhD or postdoctoral research, so that is a different area. But in learning, in terms of learning, there is no different, from my side. I hope that, because
Okay,
everything
sir.
is
Thank
open
you.
source now. Yeah.
Okay, sir. Thank you so much. I think that's all for the questions today. Thank you so much for being with us here. I really appreciate you giving us our time, and thank you for accepting our invitation on behalf of all the GDSCs of Northeast. We are glad to have you on our first day of GDSC Explore, and we hope to have you for our further events as well. Something maybe for GDSC AEC exclusively. So thank you for your time, and thank you for being with us here today. Thank you so much.
Okay. Thank you, all of you, all the team members of GDSC, from AEC or IIIT or NIT, or from all the institute. Very thankful for giving me this opportunity for interacting and delivering a session on data science. So it will be very much, it's learning, a learning lesson for me as well. So maybe in future also we'll do that thing same. Yeah.
Yes, sir. Surely.
Yeah.
Thank you.
Thank you.
Yeah.
Thanks all of you. Yeah. Thank you.